Assalamualaikum. So I'm going to show you how to use M file for RK4 method, the RK4 you have studied, for solving the differential equation. Okay, I will use this example. Dy by dt is 4 exponential 0.8 minus 0.5y. Okay, the initial value y at t equals 0 is 2, and we have to integrate from 0 to 4. So we need to solve it from time t equals 0 to 4. Okay, so as you see here, we have the M file in our manual. Okay, take this M file, copy in MATLAB. So here I have M file. You see here I have changed the file name. Why? Or function name, maybe RK4. There is a built-in function in MATLAB. So just to avoid the contradiction, so just I will use different file name. You can whatever you can name it and save with this name. Okay, so this code is based on M file. We need to delete this. Okay, better just delete all command files. Okay, no need this. Okay, so if you see here, f a b y a and n. F is the differential equation, the function we will define as handle, f handle, and a is the from time t a to b. So a is the initial the range of time, the left hand, and b is the right. So from the range from a to b. Ya is the initial value, m is the number of steps. Okay, so going back to the problem, dy dt equals, so how to define this? F equals at t comma y, then 4 times exponential 0.8 times t minus 0.5y. So here we define f. So now going back to the M file, if you want to solve using this M file, we need to copy this. Okay, if we have defined a is 0, we have to solve from time t equals 0 to 4. So 0, b is 4, y a, the initial value. The initial value at time t equals 0, y is 2. Y is 2. Number of steps depends how many steps you want to break from this interval. So this one, sometimes if it is not given, this only increment is given, you have to calculate. So for time being, suppose we have 5 points, so it should solve the value of t and y at 5 points. You can see here 0 to 4, it makes time interval of 5, 1, 2, 3, 4, 5, 6. So and it makes its own. So t equals 0, y is 2, t equal to 0.8, y is 5.14, so on. So if you want to plot t comma y, this gives you the values. You can see it is not very smooth because we have chosen like a small number of steps. So if you increase the step size, number of steps, to 15, then you will see the plot will be smooth, as you can see here. So this is the way we use RK4, and if you see, we have Euler method. Euler method is very similar. I have solved the example here, so that should not be a problem for you. This is Euler, very similar. How we just save the same file, define the f as we did, the range of a and b, the time, initial value, and number of steps. Okay. Only thing is, in Euler, when we get the results, is not very accurate to the analytical one. If you have more number of points, it will approach the analytical. Like if you increase the m to very high numbers, then it will be same as an analytical. I think this one is clear.